Hey everyone, thank you for coming. My name is Sergio. You might see me somewhere, Cuban sandwich, like online everywhere, or Search the Lion. Yeah, that's what it stands for. And today I wanted to talk to you about sync engines. I know that the title is super clickbaity. Hopefully, it's got you all intrigued. Who here has worked in real-time applications at any point in time, front end, back end? Okay, so real-time applications typically mean that the client is either, let me see, there we go. The client is either polling the backend. Aha, there we go. The client is either polling the backend or getting a server-side sent events stream, or you're running full-on WebSockets. It's a lot of work. It's complex, and it takes setting up some code on the client, setting up some code on the server, building APIs that bridge that gap, fetching data, managing state on the client. If you need real time, you are running WebSockets, or you're hitting your server a lot, and it's a lot of pain. And it's still, you get laggy interfaces, you get UI that doesn't respond quickly to changes, or you have to wait for the server. You get limited ability to have applications work offline, even if it's temporarily. Um, and so case in point being, you have a traditional web app, and now you want to add notifications in the UI so that user A doing something shows up for user B. Um, if For those of you who have worked on a scenario like this before, you might, I've talked about this, you might have felt like this at some point, right? It's crazy. There's a lot of things to do. If you have microservices and you need to bridge the gap between a client that talks HTTP or WebSocket and microservices, well, Encore can help, but it's still going to be a lot of work. Um, and we have a different problem. The expectation from users today is we're all spoiled by applications like Google Docs or Figma or Linear or Notion, where you have multiplayer all the time, out of the box, and the user doesn't even think about it, but they assume that your app has to have that. You make a change and your UI updates right away. You don't have to wait for an API call to go to the server and get back a response that says, yes, everything is A-OK. All the while, you're getting a spinner going. And the other side of it is, if you go offline, you can't continue using the app. So users expect the application to be real time. We want to give that functionality to them, but we don't want to have to go through all of these hoops. So how do we make real time and offline resilience easy? We know we have to do it. How do we make it a little bit easier? Oh, if you were doing REST or GraphQL APIs, you would, in a REST environment, you would have to poll or set up WebSockets. If you're doing GraphQL, you get queries out of the box and mutations, but you would have to still run WebSockets for subscriptions. Then you would have to handle optimistic UI. You would have to handle conflicts. You would have to reinvent syncing the data that you have on the client side, your Tanstack React query or Apollo client or whatever you're using on the front end with the server. So the way that we solve for this, or a way that we solve for this, is called a sync engine. And I've talked to some of you about this. The idea of a sync engine is, instead of having some code running on the client, how about we keep the client up to date always with all the data that's in the server? and there's a big asterisk there. I should have put it. Not necessarily all the data that's on the server, but all the data that's on the server that is relevant to this specific user that's on the UI right now. So right off the gate, that doesn't mean you replicate your entire database. It means you replicate part of your database, the part of your database that makes sense for a user. And then the client has a local database that is always in sync or very briefly out of sync, but automatically gets synced with the server, and then it can just query that. So in the past, implementations of this, there's one that was really popular a few years ago, and some of you might know about it, and it was called Meteor.js. And I've been searching for that experience for years after Meteor stopped being cool. Yeah, yes, it stopped being cool. People stopped using it. People started hating on MongoDB and GraphQL, and I wanted to keep doing that, but I couldn't. Well, but if you go a little bit further back, if you think about Outlook, or if you think about the guy that builds the library that I'm gonna show you today, he always brings up Lotus Notes. Applications used to be built to have all the data that they needed on the client, and then eventually get connected to a network of other application instances or a server for additional functionality. But the application could go offline and still work. That requires the application having access to all the data that it needs. So local database. Then Firebase did that. Supabase does that to an extent. And the difference between all of them is that they were API layers on top of a database. A sync engine, however, will get all the data updates that happen to your database and push them out to the client. And so you have a few libraries that implement that today. Zero Sync is the one that I'm going to be talking about. But you also have Convex, you have Electric SQL. TanStackDB now has something that looks like it, or TanStack now has TanStackDB. That's something that looks like it. And LiveStore from the founder of Prisma, also out. And so what does it do for you? Well, imagine you don't have to build a REST API anymore, don't have to build a GraphQL API anymore. You get a local querying capability on the client, and it figures out how to get the data from the server for you. You don't have to handle WebSockets. They're free out of the box for you. You subscribe to data, and your UI changes right away. And the client-side cache also acts as state management, because you're just running queries against your local store, and when the results of those queries change, your UI re-renders for it. That also means that if you can write to that local cache, well, you've done away with the spinner UI that tells you, hey, yeah, we're running your mutation here on the server. We'll let you know when this resolves, and then a couple seconds go by, and then you get a response, and then you can finally show the user, yes, the change you wanted to make is now done, and you can keep going. The promise of a sync engine is that that is no longer necessary. You write to your local cache, your UI re-renders, and your changes are saved. And then, it also makes it easier. If you have to write less code, there's less opportunities for somebody making a mistake, introducing a bug, and stuff like that. I'm gonna sprint through a lot of these. Real-time collaboration out of the box. Yes, there we go. Instance UI updates. Offline support built in. I talked about that. Oh man, I should have. That's a lot of slides. There we go. Okay, this is what I wanted to show you. So what you're seeing here is a screenshot. I'm going to switch to a different tab now and show you, because I figured I'm giving you a lot of promises. I might as well back it up. So This, I don't know if you can see that. Okay, there we go. F11. Yes, okay. This is zero bugs or C bugs, they call it. This is the bug tracker that the Zero team uses. They built it as a demo, and it's kind of a mock linear uh, bug tracker. And you can see I'm logged in down here. There's a few bugs that I've reported to them or discussions that I've been in. And the idea here, hold on, let me get out of that. And I actually want to show you, I want you to see that first. Come on, come this way. There we go. All right, so out of the box, the first thing that you would see is here's how you navigate this thing. And the reason that I'm stopping and saying that is there's a J and K command, like key binding. And I'm going to start typing J and K because I want you to see the speed at which this thing reacts. So if I go into one of these issues, this one, for example, I'm going to say J to go to the next one. And I clicked it and it immediately navigated. Now I'm gonna hit it and keep it pressed. Okay. So this is what you get when the data is already on the client and you don't have to go to the server to get it. Further, let's say I spin up a incognito browser here and bring it there as well. What is going on with my, let me see if I can adjust my screen resolution here. Display settings. Oh, yes, of course. Of course. Changes, 1920. There we go. That is better. Okay. So, get an incognito on one side of the screen and get zero. Ooh, no, you. This way. New tab. And I am logged in on this one. So move this one here. And see bugs.rossicorp. And by the way, if you want to follow along, you're welcome to go to bugs.rossicorp.dev. Let's make it interactive. So I am going to create a new bug. And I'm going to call it software internals demo. Oops. If I can type correctly. And I'm going to say, yay. Okay. And before, I'm going to go to bugs.rossicorp.dev here. Yes, let's go. And I'm going to look at open bugs. Okay. Save that issue. And there we go. So mind you, I'm logged in here. I'm not logged in here. Okay. So if I go to this one, and I'm going to slide down here. And on this one, I'm going to say, I need to, of course, but I can react to it on this end. Just now, no, I can't. I can barely see. I'm gonna log in. I'm gonna do another one here. Sorry. Aha, there we go. Stuff internal symbol. Okay, I'm logged in here, and I'm gonna react to it with an apple. Before I do that, I just want to make sure that you see it here. There's one here, and there's another one here. Okay. Apple. And apple. Boom. And if I hit remove here, it went away. And thank you, Alex. And then the other thing, just to show you, Alex commented. There you go. So thanks, Alex. There we go. So hopefully this kind of gives you the idea that I'm going for here. Yes, sir.
So this, you effectively have written to your local database in the browser, which then syncs with the master database and then comes back down and syncs back to your other tab.
Aha, yes, something like that. And let me see, I got my presentation here. Let's keep going. All right, so how does it work, right? So Zero is an implementation of a technique called IVM, Incremental View Maintenance. So if you work with ClickHouse, for example, or you've worked with materialized views in any SQL database, that might ring a bell to you. What it essentially means is you have raw data on a data source, then you write a view, a SQL query that does some aggregation or some filtering or some windowing, and then instead of just running that query every time that you need that data, you take the results of that query and you write them to disk. And we call that a materialized view. It's a view, it's a SQL query, but you've taken it and you've materialized it onto disk. And then you can go and query that data from disk. IVM takes that concept and makes that materialized view live and self-updating. So if you take a subset of a orders database and a new order, and you calculate a, I don't know, average order value from that data, and then a new order comes in with a different value than the average that you calculated, well, your materialized view is now out of sync. You would want to update it, but updating all the views, and if you have many views, rerunning expensive queries can be prohibitive. And IVM will take that one update to the original data set and update the result of the materialized view without rerunning the entire query. And then you can take that query and build other queries based off of that. So you can have a chain of data. And the idea there is it just calculates what should be the change, the delta, the modification to the data that is in a materialized view based on the change at the input. And it'll cascade it throughout. So that's IBM in a nutshell. And so the sync engine that I am using is the first one that I mentioned. It's called Zero Sync. It's the one that was built by the guys from Cbugs. It uses IVM on both the server side and the client. Yes, sir.
How does the client know that it's out of sync?
The client, let me see if I have, I think I have. Okay, I'll answer that because I don't have anything specifically about it. So Zero runs that algorithm, that IVM algorithm, both on the client side, so in your application with a library that you install into your application, and on the cache server. So it connects to, right now, Postgres database. There's work being done for MongoDB and MySQL by yours truly. And then other databases other people are working on. You connect it to the database. It watches the replication stream from the database. So it gets, insert or schema change or a row deleted. It puts it in a cache and then calculates the queries that your client told it that it wants. And then as data comes in that affects that query that your client wanted, it takes that delta for that query that your client wanted and sends it via WebSockets to the client.
So is the initiation of it like purely push-based?
It is, the initiation of it is, you mean on the server side, the client side?
I mean both ways. If I write to my local copy, am I sending also some sort of push message to
That's a good question. Yes. So let's talk about the data flow, right? So you have a database that is your source of truth. Zero does not replace your database as the source of truth. It puts your database on the client. So you make changes to your database. Those changes get picked up by the incremental view maintenance engine. the queries, or it saves those deltas as a stream of changes. Then one of your users logs into your app and then connects to the sync engine. So mind you, not the database. You're not hitting your database. You're hitting the sync engine. It tells it, hey, I want all the orders between a year ago and 6 months ago. That query gets turned into an abstract syntax tree that gets sent to the sync engine, and the sync engine says, this client with this client group or this role or this authentication is interested in a query that is described by this AST. And then it finds the data that it has in the cache. It takes the slice of that data and syncs it to the client via WebSockets. The client saves it in IndexedDB, and then the query resolves. The query stays live, connected to IndexedDB. So now there's more data in the database that matches that query that you ran. Replication stream puts it in the sync engine. The sync engine recalculates or calculates the change that needs to happen to the view result that your client wanted and sends that via WebSocket. The client IndexedDB gets patched and your query re-renders your UI.
Sorry.
That's fine.
No. So in the context of like, say, like a Slack channel,
Yeah.
where the data is immutable, this makes a lot of sense. How would this work in the context of something like a Google Doc, where like you have conflict? If you have local copies of the data and unfold that to the user, how do you choose which is the correct?
That is the question. So it depends on your application. You're in control essentially. If you like Zero is essentially a server authoritative model. So whatever makes it into your database, that's what's going to be the truth. It does, however, support forking on the client side, the data stream, so you can apply mutations to it locally. While those are being sent in the background to the server, they're in a staging area. Your UI renders them and your user sees that immediate UI interaction that they want, but the client side of Zero Sync has them in a staging area. Once the server acknowledges them, then it applies them or commits them to the local database. What could happen is if you have, let's say, 3 mutations, you added a comment, you reacted to like a bug, like I just did, and then you have 2 mutations in that staging area, and then somebody had made a mutation kind of at the same time, but that hit the server first, right? So that flows through the IBM engine, it flows into the client gets it, it'll take your mutations that are on a staging area, put them aside, rebase its history on top of the history that came from the server, because remember, the server is the source of truth, and then it'll apply your local mutations on top. The data or the notification back from the server will also say, yes, I've seen your mutations, here's the new total ordering of mutations that happened. And this is truth, and you can rely on it because the server is the source of truth. So in that sense, it's very different from what you would have if you built something like this on top of CRDTs, for example. Because CRDTs means that there's some fussy mechanism. It depends on the CRDT that you're using. And depending on whether you have one type of CRDT or a different type of CRDT, the resolution strategy would be different.
If I'm following you correctly, it's waiting. If you make user one makes a change,
Yeah.
And it logs that change, and it waits to see if there is a contradiction with, say, user 2 and 3 before applying that change.
Yes.
Okay, that makes
So it works kind of like Git. If you can imagine Git rebase and Git merge, that's sort of that's an intuition. It's not exactly that. Yes. Steve.
Can you roll the state back to any point in time so that you can evaluate and merge this incoming data? I'm thinking where 2 people check out the same document. The first person says, I really hate this paragraph. The second person takes that paragraph out, and then they both get checked back server. So then the result is the person says, I really don't like this paragraph. That paragraph is gone. And they're now saying that about
Yeah.
a different paragraph.
You have that.
So all of that has to be unwound in the equivalent of a git merge under some supervision. So it has to be flagged, and then there has to be some authority to decide what goes back in.
Yeah. So you have that. That is a problem that you have with operational transformation, what Google Docs uses, and that is a problem with CRDTs as well, because CRDTs, conflict-free replicated data types, and operational transformation, just mangling the story of updates. They're distributed consensus algorithms. This is not. This is what's in the server. That is the truth. So whoever had authority to make that change in the server and their change got applied, your server has that data now, and that's going to get replicated to all the clients that are interested in that data.
Can you roll it back?
You could, but it's the same you would be doing if you were rolling back data that made it into the database via an API. It's not different to that.
That's okay, as long
Yeah.
as you can recover.
Yeah. I mean,
I want the state of the data before user B checked in, so
Mhm.
only user A is checked in, and if that doesn't work, I want to go back up before user A. Then I want to evaluate each of their submissions and then decide manually what goes in. Like it would with a git merge.
Yeah, I'm sure that you could do something like that. Zero does change does save all the data, change data capture stream. So you have the inserts and updates and deletes and stuff like that. They're all saved in the sync. So yeah, I don't see why not. Aaron might hate me for this, but
Clients write
locally,
to the engine. Well, it's replicated to the engine,
yes,
right? The engine goes and mutates on the database.
yes.
Okay. Is there a lock in the engine?
A log as in what? As in,
Well, before we get to that.
you mean for like total ordering?
Yeah, you can't rely on the client's time because those are going to skew wildly.
Right.
Do you
So.
assume that all clients are hitting the same engine instance? Do you do something all the
No,
same?
they don't need to. They don't need to. You can scale it horizontally. There is one single point of total ordering though in the engine. So you can have multiple WebSocket servers, and then those get put in a queue, and then they get processed in order. But yes, there is total ordering. Yeah. Cool. Oh yeah.
So I think he's talking about like race conditions. How do you deal with race conditions? You saw there that you have a user that can make a comment, and then another user is on the same page, and they're receiving the comments. How do you, and then they can also comment or react. So how do you deal with the race conditions so that you still have?
Yeah. Yes. So I think a good way to illustrate this is think of the sync engine as a bouncer, an enforcer of access. That service will enforce total ordering of mutations.
And then that's living in the cache.
That's living in the cache, which is a server-side server-side deployment. Yes. So you can get mutations sent to that server side from many different clients. That server side will enforce ordering. Now, this is common in CRDTs where you have this concern about how do we synchronize? We can't trust clients' clocks. So maybe we use hybrid logical clocks, or maybe we do some other elaborate mechanism to synchronize writes coming from different clients. You don't need any of that because the server is the authority. And what becomes the truth is going to become the truth in the order in which the server applies it. So it's, or a replicated, like a distributed queue.
But all feeding into one. If it's the bouncer from my database,
Yes.
there's only one of those.
Yes.
Yes. Okay, so it's all funneling into one proxy instance, if you will. That's essentially proxy queries.
It is funneling into one mutation processor.
Yeah.
You can still scale it, but yes, you have one single point of failure if that's what you're asking. Yes.
How much memory do I need that?
I don't know. They're running this one on like a medium-sized ECS cluster. Not a lot. So if you have concerns about the scale, well, the wisdom in distributed databases is who here has worked on distributed databases? All right, so you maybe know what I'm going for. Sharding. You take your data, you shard it, and then each shard is responsible for a subset, non-overlapping subsets of your data on the server. And then you can scale horizontally because you have higher throughput if you can chart the data. And you just need to make sure that the way that you're sharding your data yields non-overlapping subsets of that data. Cool? Yeah.
I had actually, so what you're describing is basically like, you kind of like React, like for the database, the different of your database instead of the real DOM. The virtual DOM is basically sitting in your client. Right?
I love that question. One, I want to make it super clear that it works with any front end that you want to build with. Like, it's not specific to React. I'm using React. No, this thing that you're seeing the presentation on is built on React. And ZBugs is built on React, but it doesn't have to be. But your intuition is not wrong. You are essentially having data flow through an abstraction. That abstraction decides this little piece of data on the input means that this little piece of data changed in the output. And then that delta gets synced to the client. And then the client's query UI listens to that change and then re-renders based on that change. If you're using React and you're not careful about your dependency arrays and your hooks and stuff like that, then your whole screen renders. If you're using React by using signals, you're using something more granular, or if you're using Solid or Vue or Svelte or any of these Angular, any of these frameworks that have fine-grained reactivity, then the thing on the screen that is affected by that delta will get re-rendered. All right. Hold on. Okay, so if you're curious about IBM, you might be. Hit me up. I'll send you papers and documentation and stuff like that. It's really interesting, that IBM concept. Now, what are the benefits that we get from this? Kind of as a summary in the end. You get instant, live, resilient user experiences. You get collaboration and recovery from offline situations out of the box. You don't have to pay more. You actually will lower the utilization rate of your database server because the cache is going to absorb that data, and the client having the data locally is going to absorb most of the heavy hitting. You don't have to create endpoints and then make a change in the data model and go back and change 17 different endpoints or mutations or queries in your Apollo server or whatever you're using. You get one schema. If you're writing TypeScript on the client and the server, you got one schema that works both on the client side and the server side. Truly. Not an SDL, not an Apollo client, Apollo server SDL that gets hydrated into types on the front end, not a open API description that you can write DTOs against. No, the same schema. And it's the same reactivity on the client and the server. And then the sync engine will take care of scaling horizontally and scaling the WebSocket servers for you and keeping them synced. I have ran WebSocket servers before. I have ran replicated WebSocket servers before, mostly in Meteor, and it's a pain. And Zero will do that for you automatically. And then finally, a lot of people want this type of user experience today. So it's a matter of time before it becomes table stakes. This is not the only way to achieve that user experience. It's one of them. It's the one that I like because I've been chasing that high from building apps the Meteor way for years. And this gave that to me. So real time, instant feedback, offline, simple development, sure, all of that. It is a big change. If you're used to building API endpoints, well, that's going away. You don't necessarily have to do them anymore. You can still maybe use Zero Sync or some other sync engine for the read path to replicate data to the client so the client can read data and keep your API from mutations, as an adoption mechanism. But importantly, you don't have to continue building APIs if you don't want to. You can have your backend continue to be the business logic and the enforcer and access control and have your row level security on the backend, but then rely on the sync engine to make the UX really simple and smooth for the end user. And that is the lesson. It's all about the UX. It's about keeping the user engaged with the application, not letting them get bored or frustrated because the UI is laggy or things like that. So with that, that's the end of the slides. We've had some questions along the way, but if you have more, I'll stick around and we can talk. Thank you.